Jean Piaget, intelligence, which he defined as adaptive thought and action, develops in a necessary sequence of stages that are related to age. Adaptation is an ongoing process of assimilation, that is, transforming incoming stimuli to conform with the needs of the cell, and accommodation, that is, modifying our behavior in order to meet the demands of the external world. As a result of progressive assimilation and accommodation, thought and action become increasingly organized, flexible, and freed from the domination of immediate perception. During the first sensory motor stage of development, from birth till about 2 years, children construct a world of permanent objects. They learn that there are things outside their own bodies that exist independently of themselves. Then, from about the age of 2 to 6, the pre-operational stage, children progressively represent this object world and the relations between objects with any number of verbal and nonverbal symbols. They learn to recognize and to label literally thousands of objects, descriptions, and relationships. Symbols are not just words. Using knee socks for gloves, associating candles and a cake with birthdays, and building a block telescope are all examples of symbolic thought. With the emergence, around the age of 6 or 7 for most children, of the concrete operations, children begin to construct the world organized into units and regulated by rules. As school-age children begin to address the world in terms of units and rules, their thought is progressively freed from what they perceive. But as the name of this stage suggests, their thought is still very much rooted in real things and in the here and now. Hello, I'm David Elkind, and this is Janet Murphy, whose classroom we'll be using today. We'll be doing interviews with children to demonstrate some of the changes in children's thinking that Piaget described as concrete operations. With these materials, we will demonstrate the 2 processes that Piaget described as marking the appearance of concrete operations. These 2 processes that Piaget called transitivity and reversibility are major achievements of the concrete operational period. In turn, they make possible the construction of 2 equally important conceptions, namely those of rules and those of units. In this film, we are going to present children with a variety of tasks that require them to make judgments on the basis of either reason or perception. When children make their judgments on the basis of transitivity or reversibility, they give evidence that their sense of logic takes precedence over their perceptual impressions. They demonstrate, therefore, that they are using concrete operations. Transitivity, or deductive logic, is a mental process we use all the time. For example, if we compare stick A with stick B and see that stick A is longer than stick B, and then compare stick B with stick C and see that stick B is longer than stick C, we can conclude that stick A is longer than stick C without comparing the 2 directly. Transitivity involves holding 2 relationships in mind at the same time. We can illustrate the development of transitivity by presenting children with Piaget's seriation task. I'm going to take these sticks and I'm going to make them into a ladder like this. See? I have another set of sticks. I want you to make a ladder just like mine, okay? Make a ladder just like mine. So it's smallest, next biggest, next biggest, next biggest, next biggest, biggest. Okay? Very good. Is that just like mine?
Maybe.
Okay, now let's just do it more simply. Why don't you make a ladder just with these three? Can you do it with just these three? Make it just like that, okay? Is that right?
Right.
4-year-old pre-operational Jeffrey has difficulty with this task. He is unable to order 3 sticks according to their length, even with a model to copy. He simply does not understand the relationships that are involved. Some critics argue that young children's failure to solve such problems is a matter of misunderstanding the language involved. They say that young children simply do not understand the terms next largest, smallest, etc. Piaget's answer is that young children do not understand the quantity terms in the adult sense because they do not as yet have the underlying concepts of transitivity and reversibility that enable us to comprehend and utilize mathematical terminology. You make a ladder just like mine, okay, with those sticks. Or a stairway just like mine. Meredith, who is also 4, was at first as confused by the seriation task as Jeffrey was. She simply straightened the sticks as he had done. But when I showed her how they were ordered according to size, she was able to locate the longest and the shortest. Her logic had matured enough to use the information I gave her. She was still, however, unable to deal with those sticks that were of intermediate length. Meredith could seriate the sticks when given only 3. Is that just like mine? Okay. We can see the difference concrete operations make in the performance of 7-year-old Renee. The task is very easy for her. She clearly understands transitivity and can hold 2 relations in mind at the same time and understand that one stick can be both longer than some sticks and shorter than others.
It was smaller than that one.
So it could be both smaller than this one and bigger than this one.
Mm-hmm.
And that's okay? It could be bigger and smaller at the same time?
Mm-hmm.
Oh, okay. In addition to enabling children to order elements in a systematic way, transitive reasoning also enables children to understand and operate according to verbal rules. We can see this understanding of rules in this hopscotch game where a girl gives up her turn because she understands that she has overthrown her marker. Likewise, these children in Margie Wong's first grade class are using transitive thinking with this board game. They are operating according to the general rule, move your token as many places as the spinner says. The spinner says 3. Therefore, I move my token 3 spaces. The attainment of transitive thinking and the resultant ability to use and follow rules have far-reaching social and academic implications for the child. We must now, however, turn to the second logical process we are discussing, reversibility. Reversibility, in combination with transitivity, makes possible the other great achievement at this stage of thinking, namely the unit concept. Reversibility can be attained by the use of either of 2 sub-processes that Piaget called compensation and reciprocity. The compensation sub-process involves the recognition that one operation can be annulled by another. The reciprocity sub-process involves the recognition that what a fixed quantity gains in one dimension, it loses in another. We will look at compensation first.
We were talking about dinosaur eggs, right? And the dinosaur laid 2 eggs, and then the dinosaur laid 3 more. So now the dinosaur has 5 eggs all laid in her nest. And Oviraptor comes and steals and eats 2 of them.
The sub-process of compensation is illustrated in the story of the snatching of the dinosaur eggs. The concrete operational child understands that the arithmetic operation of addition can be compensated by the arithmetic operation of subtraction. Later, he or she will learn that the same applies to the mathematical operations of multiplication and division. Children can also attain reversibility with the aid of the process of reciprocity. We can observe this process in the next interview. I'm going to take some pennies from this pile so that I have this many. Can you take the same number of pennies as me? Just take the same number of pennies in my pile. How many do I have? 6. Good. I'm going to put your pennies over here like this, right next to mine. Now your pennies are here in this row. My pennies are in this row, right? Do we both have the same? Or does one of us have more?
We both have the same.
Okay. Now I'm going to spread my pennies out like this. So my pennies are in this row and your pennies are in this row. Do we both have the same number of pennies, or does one of us have more and one of us have less?
We still have the same.
When 7-year-old Renee compares 2 rows of 6 pennies, in one of which the pennies are spread out and another in which they are close together, she can recognize that what the spread out row has lost in density, it has gained in length, and so is the same as the row of pennies close together. She has thus achieved the unit concept of number. According to Piaget, a child gives evidence of having attained a unit concept whenever he or she judges a quantity to be the same despite a difference in its appearance. This general recognition that a quantity can be both the same and different from other quantities is what Piaget calls conservation. There are steps leading to this achievement. 4-year-old Jeffrey can count but has not yet attained the conservation of number.
Can you tell me if this row or this row, if these have the same amount, or if one row has more or one row has less?
More than.
Young children, like Jeffrey, have what Piaget calls a nominal sense of number. When we use a number on a jersey to identify our player, we're using a number in the nominal way, simply to name the person in question.
See if you can tell me again, which one now is the number 3? Look at that, you did it right away.
Number used in a nominal way has no quantitative meaning. Young children of 3 or 4 may be able to assign numbers to objects or to read numbers, but this is still a rote matching. It is not true counting. It can be misleading to adults who are eager to have children achieve academic skills early. Around 4 or 5, many children attain what Piaget calls an ordinal concept of number. Number used in an ordinal way amounts to a ranking without units. When we say that a soccer team is number 1, this means that it is better than team number 2 and team number 3, but we cannot say that team number 1 is twice as good as team number 2 or 3 times as good as team number 3. Children demonstrate an ordinal concept of number when they successfully arrange a set of elements according to increasing or decreasing size. Through maturation and many experiences of dealing with quantities such as filling and emptying, measuring and counting, children gradually come to achieve conservation of number, or the mathematical unit concept. 4-year-old Jeffrey has attained the nominal concept of number. He can count well, as we have seen, but has no understanding of the unit concept. For him, 6 pennies spread out are more than 6 pennies spaced closely together. But count them again for me. Can you count your pennies and then count mine?
1, 2, 3, 4, 5, 6.
Very good.
1, 2, 3, 4, 5, 6.
So, these are my pennies and these are yours. Do we both have the same?
You mean all of these are moved? You don't count these?
No, but we have to count them all. So we count, but these are my pennies like this and these are your pennies. So do we both have the same pennies, or do you have more, do I have more? The hard one. Suppose I put my pennies back together like this. We both have the same?
Yes.
Ethan, also 4, is at a transitional stage. He demonstrated the ordinal concept of number, the comparison of size relationships, when he questioned me as to which pennies he was to compare. He senses that quantity relationships are involved, but his ordinal concept of quantity does not suffice to solve the problem. When we perform the same experiment with 6 or 7-year-old children, however, we observe a different pattern. Renee, with her new ability to use reversibility and transitivity, recognizes that the number of elements is not changed by a change in their appearance. She grasps that the rows and the individual elements within them can be the same and different at the same time. This is the essence of the true unit concept. Every unit is both like every other unit in that it is a unit, and different from every other unit in its position or order.
Why did he say he has eaten all the cake? Now he has no cake for his party.
Another domain in which we can see the importance of the unit concept is in beginning reading. One requirement for children to read is that they understand that one and the same letter, for instance the O in spot and the O in nose, can represent different sounds, and that the same sound can be represented by different letters. That is to say, the child has to understand that the letter is a unit and remains the same across transformations of sound and appearance, upper and lower case, script, and print. Although children can learn sight words at an early age, they really do not grasp English phonics until they attain concrete operations and can construct the letter as a unit concept that remains the same across visual and auditory transformation.
Yes, good for you. Thank you, Tony.
When a child attains a unit concept in a particular domain, that's no guarantee that he or she will automatically have attained the unit concept in other content areas. Indeed, Piaget argues that each content area has to be constructed in its own time and in its own way. Indeed, for older children and adults, they too encounter difficulty when the material to be conceptualized isn't broken up into discrete parts. We can observe this as children attempt to conceptualize mass, weight, and volume with clay. Now we have two balls of clay. They both have about the same, do you think?
I see.
Okay. Now this is mine and this is yours. I'm going to roll yours into a sausage like this. Or a hot dog or whatever.
A hot
A
dog.
hot dog, okay. Hot dog's better. And so, you have a particular kind of hot dogs that you like best? Is there?
I think Parmesan. Parmesan.
Oh, Parmesan. Okay. And so this is your
Parmesan.
Farmer John's hot dogs. Oh, okay. Boston, we have the Red Sox hot dogs. Do we both have the same amount, or does one of us have more? Ethan, what do you think?
One of us has
Ooh, which one? This is yours and this is mine.
mine.
Oh. Suppose I put them back in a ball, making them into a ball again. Will we both have the same again? Suppose I'll make it back into a ball again.
I think so.
Each domain presents its own resistance to being conceptualized. Piaget wrote that learning is as much a matter of giving up old ideas as it is of acquiring new ones.
Can you take a look at those two, and can you tell me which one of these has more clay, less clay, or are they the same?
This one has more clay.
More clay. Okay, and why do you think that?
Because this one is in the air and that one's better.
Renee, at 7, has no problems with seriation or with conservation of number. She finds the experiments dealing with mass, weight, and volume more difficult.
Again, remember in the beginning we had the two balls. Now, does one of them have more clay, less clay, or are they the same amount now? Same amount now. Okay. So when they're in the two balls, they have the same amount. But if I roll this one back into a hot dog, then tell me one more time, which one? Does one have more or less, or are they the same amount of clay now?
Same.
They're the same now? Okay, last time we did this, you said that this one had more. You changing your mind? So when they're both balls like this, do they take up the same amount of space, more space? Does one take up more space or one take up less space?
They They take up the same
Okay, good.
space.
Okay, and I'm going to take this one again and make it into a hot dog. Do they take up the same amount of space, or does one of them take up more, or one take up less?
This one takes up more.
This one takes up more?
Mhm.
Okay, and why do you think that?
Because it's stretched out and it doesn't have as much room as above.
Oh,
It has more room.
so it seems to take up more space.
She eventually succeeds in conserving mass, but gives in to her perceptual intuition that the sausage takes up more space than the ball. She has not yet attained the unit concept, as it applies to the intuitively more powerful concept of volume. In short, when a child gives evidence of having attained conservation in one domain, this is no guarantee that she or he has applied these operations to all domains. And it is the same for the attainment of the next stage of logical thinking, formal reasoning. Namaka at 9 can easily deal with a task requiring conservation of one dimension. Now, this is mine and this is yours. Does the sausage take up the same or more or less space than the ball, do you think?
The same.
The same, really? How is that?
You didn't take anything out.
But she has difficulty when the task involves the interaction of two dimensions, weight and volume.
They look equal to you?
Yes.
Okay, great. Okay, now we're going to put the box with 15 pennies into this one and watch what happens to the water there.
Okay.
There we go. Okay, what happened to the water there?
It sunk. The
The,
water rised.
the water rose because the box sunk, right? Okay, we're going to do the same thing over here with the box that has 25 pennies in it. We're going to put it in this one. But I want you to predict with this rubber band. I want you to put it around the box. And you move it up and down and tell me where you think that water will go to when we put this one in there. Can you do that for me? Just make your best estimate where you think it'll rise to or fall to.
There.
Okay, ready now? Let's make sure it's kind of even. You want to go down to there? Does that look even? Okay. Is that where you'd like to have it? Okay, here we go. We're going to put this one in and see what it does. Okay. What do you think happened there?
The water rose.
Okay, and let's take a look between this one and this one. What happened?
They got even.
Intuitively, the heavier box should make the water rise higher, but of course it does not.
I want you to show me how many different ways you can put these colors together using 3 bow ties.
Well, that'd be blue, red, green, blue, red, yellow, blue, green, yellow, red, green, yellow, red, blue, yellow, yellow, green, blue.
Great. Okay, and how about if you were using 4?
Namaka can handle the advanced combinatorial task of putting the macaroni bow ties into groupings. She experiences difficulty, however, with a purely verbal transitivity task. Mary is taller than Joan, and Joan is taller than Grace. Who is the tallest of the 3?
Jonas.
Very good. Why is that?
If Mary's taller than John, but John's taller than Grace,
Mary's taller than Joan, and Joan is taller than Grace. Who's the tallest of the 3?
Mary.
Okay. At 9, she thus gives evidence of having attained formal reasoning in one domain, but not in another. It will take time for her to learn to apply formal reasoning to problems that are posed verbally. To go to the other end of the spectrum, some investigators, critical of Piaget, argue that children can attain conservation and unit concepts before the age at which they usually attain concrete operations. In these experiments, however, the researchers change the nature of the task. For example, when 3 rather than 6 elements are used in the number conservation task, even 3 or 4-year-old children recognize that they remain the same when spaced apart, as we see here with 3-year-old Brian.
Okay, Brian, now we have my pennies in a row right here, 1, 2, 3, and your pennies right here in a row, 1, 2, 3.
It's an H.
It would be an H if there was a line in the middle, wouldn't it? What if I do this to my pennies? Now, does one row have more or less, or are they the same?
They're the same.
Notice that Brian first saw the pennies as an H, or as a figure, which Piaget regarded as characteristic of young children's approach to such tasks. Yet the child's success is a result of making the task easier. With just a few elements, the child can reverse the spreading apart perceptually and without recourse to the logical operation of compensation or reciprocity. Neither reversibility nor a unit concept are required for judging only 3 pennies. For most of his long and illustrious career, Jean Piaget wrote as if children spontaneously maximized their intellectual abilities. Towards the end of his life, however, he began to elaborate on the role of experience in children's mental development. He and his colleagues undertook a number of investigations in which they demonstrated that experience indeed could help facilitate intellectual development, although they also demonstrated that the degree of improvement was itself dependent upon the child's intellectual level. We experienced an example of this during the filming of this program when 4-year-old Ethan did not react to the optical illusion as we had expected. Now, these are the same 2 lines. Are they both the same now, or is one longer than the other?
They're the same.
They are? Really? Doesn't this one look longer than this one? Look closely. Doesn't this one look longer than this line? What do you think?
Yeah, but I think they're the same.
Why is that? Don't they look longer?
I saw it on the rainbow thing.
Oh, you did? Oh, well. Ethan, who's on the threshold of concrete operations, as we have seen, was able to use a television experience to help him deal with our interview. He cannot explain the logic of what he perceives, but we can see the intentness with which he is trying to use previous knowledge to further his current level of understanding. Towards the end of his career, Jean Piaget thus moved closer to the work of famed Russian psychologist Lev Vygotsky. In his writing, Vygotsky argued that there was a zone of proximal development that left an opportunity for adult intervention to facilitate the child's intellectual growth. He called such interventions mediation. We know that good teaching always involves helping children move ahead from where they are by presenting tasks that are challenging but not daunting. It is Piaget's understanding of children's thinking and his respect for it that will continue to be a model for all those who work with children. He never regarded children's thinking as lesser than that of adults or adolescents, just different. He left us methods and terminology with which to explore the differences. The work of Jean Piaget has opened up many new areas for discussion and for investigation. His description of the stages of logical thinking and the unit concept have many implications for education and for the helping professions. We hope that this film and others in the series will encourage you to incorporate some of these insights into your own work with children.